All right, well, hello everyone. Today I'm going to be explaining the countercurrent multiplier and countercurrent exchange of the nephron loop. As you can see here in my drawing, we have the glomerulus here, okay? Glomerulus capsule surrounds the glomerulus. These are the peritubular arterioles, I would say. This is also the proximal tubule. This is the distal tubule here. Okay, this would be the descending tubule. Okay, this would be the loop of Henle that goes around here like a U. This one here is the ascending tubule, and this would be the distal tubule. As we can see, it's because it's more distal to the glomerulus here, and the proximal tubule, it's closer to it. Okay, and then this, or we should say filtrate, will come into here into the collecting duct, and eventually will become urine. Okay, so the countercurrent multiplier, okay, has filtrate coming out of the glomerulus. So here, filtrate comes out of here. Filtration of the blood, it's mainly takes place here inside the glomerulus. Okay, so as filtrate comes out, okay, it becomes more concentrated the deeper it goes into the medulla. So we would say about half of this drawing here, the upper half could be the cortex, the lower half could be the medulla. Okay, again, because the descending loop of the nephron, okay, is permeable to water, the surrounding interstitial has a higher solute concentration. So the interstitial space is just right outside here. Okay, cells in the ascending nephron, which is right here, okay, transport solutes into the interstitial space, but it's not permeable to water. Okay, filtrate becomes less concentrated as it moves up. Okay, so as it goes up, okay, water is not permeable here, but the again, the solute, there are solutes outside in the interstitial space. So filtrate becomes less concentrated as it moves up. Concentration can get as low as 50 milliosmoles per liter. Okay, now as filtrate goes through the distal tubule, so right here, okay, it goes up here, okay, and into the collecting ducts, even more water is reabsorbed. ADH, which is anti-diuretic hormone, can cause insertion of aquaporin channels that allow water to leave the tubules. So water comes out of here with the aquaporin channels and flow into the interstitial space where it gets picked up by the capillaries. Okay, so water comes out of here and gets picked up. Okay, now another important thing would be urea has an osmotic pull on water, and about half of the urea is reabsorbed. So urea comes out, for instance, at the loop of Henle, comes into the interstitial space, and water follows it. And then urea will then make it back to the nephron loop, where it will be dumped with urine. Okay, so it's like a recycling mechanism where urea comes out, water comes out, urea comes in, and then it goes and exit or dumps with urine. So that is the countercurrent multiplier. Okay. Now I'm going to explain the countercurrent exchange. Okay, the vasa recta are the peritubular arterioles. Sorry, I don't know why I keep saying peritubular. So it's all these red lines, okay, small arterioles, okay, and we know that arteries carry oxygen, or it's the blood in the arterioles are high in oxygen, okay. So again, the vasa recta are the peritubular capillaries that dip into the medulla and surround the nephron loop. Vasa recta supplies the cells of the medullary space with oxygen and nutrients. It also facilitates reabsorption of water. Okay. By running countercurrent to the flow of filtrate, the vasa recta is able to pick up solutes in the ascending side, which also facilitates reabsorption of water on the descending side. This process is known as the countercurrent exchange. So, just so that I can show you, as filtrate, the vasa recta is here, and it comes down here, right? Because eventually it's going to make it back into this renal vein and flow back into the heart. Okay, so as the vasa recta comes down here, okay, it's able to pick up again the solutes from the ascending limb that come out. Okay, remember this tubule here is not permeable to water, but the solutes are able to exit, so then these arterioles will pick up the solutes, okay, and then as it comes up through the descending limb or descending side, not limb, sorry, it also reabsorbs water, okay, that's out in the interstitial space, because remember, through the descending limb or tubule, this side is permeable to water, so any water out here will be picked up by the vasa recta, and then go back into the renal vein and into the heart. And yep, that is all, and I hope you enjoy this video.